Hello, hello.
Hey, what's up, guys?
What's up, everybody?
Hey,
How's everyone doing?
not bad.
How's it going?
Pretty good. Pretty good.
I'm already a few of these down. I just did a really awesome interview with an Australian dude, so I was drinking Foster's just to be disrespectful. So,
Bob, have you ever done an interview sober?
I think once, maybe.
All right. Well, it's been what? I think it's been an extra week this time.
Yeah, it's 3 weeks.
But I don't know if we'll get to another one this month, but try to keep it regular. Just like I do with Metamucil every day. So, who wants... Oh, you know what? I take that back. We should go around and introduce ourselves. I remember somebody mentioning this in comments, that we've gotten out of this habit, and the people that listen over audio would like to learn voices, I guess, for some reason.
Gotcha.
So I'm Nick. I'm one half of HD Retrovision, which, for those of you who don't know, is a long-distance running team.
I'm Bob from RetroRGB, which is a website about alcohol addiction. Nick, you forgot to introduce your mustache, though. I think it requires its own introduction.
Stashy?
Stashy, did you have to register that on any list? I won't ask specifically what list that might be, but is your mustache
there's
registered?
a website you can go to, and it'll give you a plot of your neighborhood of all the men with mustaches. I have to keep this at least 1,000 feet away from any elementary school.
A crime has been committed.
All right.
Who's next?
Yeah, go for it.
My name is Voultar. First name is Lord. I give these guys hell on a bi-weekly basis, and that's pretty much all I have to say about myself.
I'm Rene from Canada. I'm the only engineer within like 1,000-kilometer radius here, and the the resident cold weather expert.
It's pretty cold here too, man. We had quite a bit of your weather drop down here lately.
I'm Steve Kulov, the first half of HD Retrovision, I guess. And I don't know what Nick's talking about, but we're a sprinting group, not a long distance group. So
It's more of a cult than a group. I mean, you can join, but you can't quit.
no, yeah.
So for those of you who are new, probably nobody, because who's telling people that they should join this thing anymore? We're going to go around the table and talk about kind of what we've been up to, or interesting topics that we want to cover. And then we have one interesting group thing to chat about a little bit, having to do with testing and validation this week. And then we're going to answer a huge list of questions that keeps growing larger and larger because we never get to all of them. So who wants to start?
I'll go first.
All right, let me pull up your...
Well, pull it up and hold off on that. I want to talk about something before that.
Okay.
If your mustache will allow it. The things that I've been working on lately, AES, RGB modifications, Commodore 64 stuff, that is all still very much in the pipeline. My hands are tied because I'm waiting for parts. Particularly with the AES, I'm waiting for two things to come in to sort of polish things out and get things in a pretty good state. But in the interim of doing that, I think I've been working on some pretty interesting things. The one-chip SNES, for example, that's a conundrum in itself. There was a thread on Shmups about certain ghosting issues that affect some, but not all one-chip ASIC SNES systems. and somebody sent me one that had a terrible ghosting issue, and I did some signal analysis, and kind of by luck, I found the problem, or an explanation to the problem. There's a capacitor on there on the ASIC on the DAC side of the one chip that is sort of it's part of a compensating node. Nick, what is that picture doing? You just totally threw me off.
Sorry.
Yeah, that's
I'll
not
minimize
the right
it.
picture. That's not the right picture.
Not the right picture.
No, it's okay. I didn't send you a picture for this, Nick. But at any rate, so on the one, it's okay, Nick. It's all right.
Yeah.
Your mustache.
This is the picture you sent me. It's
Right,
just,
right. But I said
I'm
I was gonna
early.
hold off on that. I was going to talk about something else first, Dick. I'm sorry, people, for this terrible show.
This is a disaster.
A bit
Let's just
complicated.
quit and go home. No,
But-
go ahead.
No. We're doing good. But anyways, like I cracked the code on one chip ghosting. I looked at it for over the weekend. Steve helped me and sent me some really good information on current steering and stacking DACs and how they work. So we looked at this, and the C11, it's the capacitor on the board. It just doesn't have the gas to stabilize the current and the voltage. So what happens is if you have a one chip and you have ghosting, you'll see from the top left of the screen, almost to about mid-scan line, in other words, half of the screen, you'll see these bars, and you'll see a lot of ghosting effects. Well, that's because that the feedback network is fighting this current, this voltage variance. So it swings high and low and high and low, and the capacitor doesn't have enough charge to stabilize it until it draws about half of that raster line, and then things start to look good. So the solution is very simple. You don't have to lift any pins or legs on the one chip. You just actually correct the problem where the problem is. Replace C11, that includes both the one chip FAT system and the SNES Mini. Replace C11 with anything greater than 300 nanofarads, but anything less than 1 nanofarad, or 1 microfarad. So 470 nanofarads is perfectly reasonable to use to replace C11, and you'll remedy your ghosting issues and your other sort of voltage distortions that show up on the waveform. I documented this. I provided scope plots. Well, actually, Steve provided my thumb drive. I lost in my butthole, and so Steve grabbed some plots for me because I had them. I just had no way to digitally store them. So he was a big help on this, and I posted scope plots and sort of the whole theory and then the analysis, and so that's a pretty big deal. The ghosting issues on one chips, either you have it or you don't. In my experience, more systems don't have it than systems have it. Did I say that right?
Yeah.
Yes.
Which is also, yeah, it's true. I found the same thing.
So there was a big sort of when these things happen, there's always often they're followed by a huge misinformation campaign. No one should freak out over their SNESs. The good news is finally at last there's a very simple and extremely reasonable solution to line your video out on your one chips. Now, I hope Bob has that information on his website soon. As far as this problem, he's really slacking in just about everything. So, but I would look to RetroRGB to have a nice, detailed posting of this, as well as all the nice screen captures and all those scope plots and everything like that. So,
can I point out just one thing? I think it's important.
Yeah.
This wasn't just like random. You were testing out different caps. You were like stacking them in parallel, trying to find the optimal capacitance, and then I was over here stacking some whatever I had in series, and we ended up like at the same values.
right.
So it wasn't like random. It was like pretty scientific. We came to that right middle ground because we didn't want it too high to screw everything up, and too low is what caused the instability.
What's interesting is when I received this system, and because a lot of people were hounding me over this, not in a bad way, they're just like, it'd be really awesome if you could look at this. Sure, I'll look at it. I got the system in, I turned the board upside down, and I was just looking for components that were in close proximity to that ASIC. And it was really just by luck. I thought C11, because I was an idiot and I was tired, was just a bypass cap that was supplied directly to the DAC. And I'm like, oh, okay, well, I'll take a look at this. And I swapped the cap out, and all the problems went away. And it actually turned out not to be a bypass cap. It's actually it's the pin 154 on the ASIC is part of the sort of compensating node that helps stabilize and keep the signal from swinging. So I talked to Steve, and Steve was like, you should probably be careful. You don't want to put too big of a cap on there. Because if you do have too much capacitance on there, it's possible that you could affect the slew rate or the bandwidth in terms of how fast your pixel transitions are and how much content you can jam in there. And how the speed between pixel transitions. So him and I together, I just started stacking capacitors in parallel. I started with 100 nanofarads. It helped it some. 200 nanofarads helped it, more, but there was still some left. I got up to 300 nanofarads, and things looked great. And then I jammed all the way up to 4.7 microfarads. And then I found that anything over than 300 nanofarads and anything under 1 microfarad, you didn't your pixel transition time stayed nice and fast. That really wasn't affected very negligibly, if at all. So yeah, we did that, and that's a pretty big deal. I guess that's plagued a lot of people, and I hope that more people sort of propagate that information out there, because I was pretty happy with those results. So
I know this is your topic, but this is a really important thing that you've discovered. So I got like one or two very short questions, because this I'm not trying to hijack, but you stumbled across like a big thing here. With resistors, it's just my default that I go to 1% tolerance because they're very inexpensive, and I don't think I could ever perceive anything more than 1%. Capacitors, the tolerance levels on them, they're way more expensive the lower you get. I believe almost everybody in these production units used 20% tolerance. The ones that we've spec'd out, the ones that you sent me the links for, were 5% tolerance. Would you see any material difference if people tried to buy the really expensive 1%, or is it not? It's not enough of a swing on this.
I think even with 470, 20% is fine.
Yeah,
it's because where the problem lies was around like 40 nanofarad, and so if you had 20% of what was stuffed on there originally, which was 47, that could go up to like 56 and 30 something. And that's where the problem was, but we're way out of range of that area, even with 20%. So,
gotcha. I mean, for us, the price difference is so negligible. I would just say get the 5%. We're not a company making $1 million. That 8 cents isn't going to break our bank.
I think it's more important to get the right size, because the mini, it's a 0603, and on the one chip it's an 0805. And then I would also I prefer X7R dielectric. X7R, X5R, I don't get anything that starts with a Y or a Z.
Okay.
Yeah.
They have bad temperature characteristics.
And for anybody that doesn't know what these numbers and letters are, don't worry about it. I'm going to make sure to link to the exact ones that these guys recommended.
So other than sort of my one chip findings, and really just finally solving the case on this issue, I've been doing a lot of trying to catch up on all this mod work and all these orders. I get overwhelmed every day, but I enjoy it. I love helping you. I love helping your bodies in an intimate way. And something else kind of interesting, Retro RG Bob has this tendency to send garbage to my fucking house about every other week.
Not always garbage.
He actually sent something. There's some jewels in there, but he actually sent me something. He thought wasn't working, and it might very well not still be working. Right, but he sent me a Datapath Vision E1 capture card, and I got to tooling around with it a little bit. Pretty damn impressive little piece of kit. The only problem that I have with it, which just makes it kind of clunky, is you have a DVI interface, which is fine because I'm sure this card was intended to interface with sort of newer, non-legacy, video modes or video formats, right? So I decided, Nick, you can bring that picture up now.
Yeah, it's up.
Yeah.
It's been up.
Oh, okay. I don't see it up on the YouTube chat, but whatever.
It's a delay.
Okay, it's a delay. All right, so I designed just yesterday. Not spent a whole lot of time on this. I designed a video interface for this particular capture card. So what this will allow you to do, if you want to connect a SCART interface, if you want to connect a VGA interface, if you want to connect a component interface, you can do that seamlessly with this board without a jumble of wires, without 50,000 little converting dongles and things like this. And
you don't need a tool belt full of like little adapters.
Well, that's, in my experience with a lot of these capture devices, that's just kind of the problem. Something like this, which I need to send back to Bob, it's another jewel, like this Epiphan. It's great, but you have to, if you really want to get good versatility out of this, you have to do so much to convert into this DVI interface. So this is a sort of catch-all little interface board that I designed. And the only thing that's required is that you supply a DVI cable that'll go from the capture card to this interface box. And so, and another thing to sort of help quell certain corner cases where sync might be an issue, I've also integrated a sync stripper that terminates, which is toggleable, which you can toggle. You can either pass your sync directly through, or you can shape it out with an 1881. So you have excellent compatibility, but that's something I whipped up, and that'll be available for people extremely soon. It's finished. So that's what I've been doing. Any questions on any of that?
Nope.
No questions, but I'm going to tell you right now, that will make a lot of guys who do the Twitch streaming stuff very, very happy. Guys and girls, human beings. Like that's going to be like the amount of cables that are going to be needed cuts in half. You could have. Oh wait, I do have a question. What happens if you have multiple things plugged in at the same time?
So this is a very stupid little dummy device. It does not mux your inputs. So if you want to have something connected, you really only need to have that thing connected. So I wouldn't jam things into your component input if you have a SCART a SCART input in there too. But one thing, I'm glad you mentioned that. Something that it does mux and do is, of course, the Datapath doesn't have any sort of audio handling, right? Well, if you look at the picture there, right next to the DVI on the top left-hand corner, there is a TRS stereo module. So what you can do is, if you're running SCART or your component in there, you've got a TRS audio jack. You can just jam that into the line in of your computer sound card, and there you go. You can capture audio and you can capture your video all on the same interface with very little fuss. Very cool. The reason I asked, I didn't want it to turn into like a live switch, but I just, for people that have different sources. This is actually a great question for all you guys. What are the negative effects if you have a VGA console like a Dreamcast, a SCART like SNES, and then component like PS2, and they're all off, and then you turn one of them on? Is having the rest plugged in going to make that much of a difference for video capture? It depends on what's on the outputs. It depends on, like the PS2, for example, what sits in between the multi-out and Steve can answer that a lot more eloquently than I can.
Yeah, it's going to be dependent on the like whatever's driving those outputs on the device that's off. In most cases, though, you have protection diodes on the outputs of those driver chips. So when those are in an off state, and they're connected to the same bus that of something else that's driving like into your the data path device, it's going to leak a little bit into your into that off device. So you're going to get some leakage, and it's going to be a nonlinear distortion because diodes are nonlinear. So even if you get like some, you might notice some brightness variation, but it's not uniform throughout the picture. So your brighter content is going to be more reduced than your darker content. So it's not something that can be easily fixed with adjustments. So I wouldn't recommend it. If you need to do something like that, interface some sort of external switching box to be able to switch things out.
Gotcha. I'm very glad I asked, because actually the guy that I was asking for just jumped on chat, so I'm glad he's here listening to this, because he's going to use the shit out of this. I know it. So,
I mean, you could try it, and you can see it, how much it gets affected, and if you have no problem with it, then great. Just you could go ahead and use it. This is the same effect you get when. Do you remember those multi? Like S video cables, like a Pelican, like long back in the day, like they made this thing with like an N64, PlayStation, N64, Dreamcast, and it's an S video cable. If you had two hooked up at the same time, and one was on and one was off, and you look at the screen and then you unplug that other one that from the off, you'll see the brightness like come up a little bit. It's because it was leaking into the off console.
Right.
Did the people who used to make those tell you not to do that? Like, was there anything?
I don't. That's a good question.
It said all over all of the instructions, do not plug more than one console in at the same time.
Oh, okay. Oops.
I mean, I did it too, but
I could, Bob, I could implement I could implement a sort of safety mechanism for that, but
I wouldn't bother.
For the scope of what this is, it's just common sense. You really don't need to do that.
I wouldn't jump to saying it's just common sense. I would just jump to saying, unlike certain people, if you decide to sell a few of these, just put a little sticker, just one of them little labeling things, only one console at a time. That's all it takes, a couple cents.
Or you mean just have some sort of documentation period for something?
Anything, or you could just blame
just
Super
on the
G.
silk screen.
Yeah, I was about to say, just put it on the silk screen.
Actually, Zach, could you do that? That's actually the perfect answer.
that way, if people who make their own order their own, just already have it on there.
But I mean, I think it'll be useful to the people who have one of those cards. I mean, it's ported for standoffs in the center though, so you can either just put it on plastic pedestal standoffs, or you could even, like the Sync Strike, you could mill out some Lexan or some acrylic, and you can make a nice little case for it. It's got the designations for that. So I don't know. I thought it was something real simple and kind of fun to work on. That's actually serves an important use for people.
Yeah, huge. That's awesome. Thank you for that.
Oh, thank you, Bob, for sending everything.
All right, Bob, your turn. What have you been up to?
Well, I kind of had the rug pulled out from under me today when a couple of my alter egos got caught out on shmups. I got my accounts. Oh, sorry. I've been checking out Raspberry Pi hardware solutions. They're things that I've had for 6 months now, but I didn't. I wanted to make sure that I was only testing hardware because there's so many different software things, and I just wanted to make sure that my comparisons were just based on the hardware. And what you don't see in my, my awful, I wish I could someday be like My Life in Gaming videos, is that, the hours and hours of testing and research. I don't waste I always try to make the videos as short as possible. They usually end up like 15, 20 minutes. But I really did test a lot of screenshots, a lot of talking to the developers, the ones that would get back to me. And it's, to be honest, I like every one of them. And all of them are just whatever is the best use for your situation. So I've been doing that. The video's up. I'm not going to waste anybody else's time. And me and Ben from iFix Retro, we pulled apart like 5 or 6 PS2s to test the different C-Sync or the C-Sync mod on it. and it works great. We haven't found one that didn't work yet. What we did find was that the 3000 series PlayStations, when you do the mod, it is what I would think is the perfect thing for a PlayStation. You lose Luma, but every C-Sync is on it through all resolutions, and composite video is untouched. So if for whatever reason you still want to use it, maybe you got, RGB through a BVM, but component or a composite on like a regular consumer grade TV, you could still use that. And component video is not affected by the mod either. So it's been a fun couple of weeks of nerding out.
Nice.
Cool.
All right, I'm passing the ball to Rene. I haven't heard his voice in a while. I miss it.
Yeah. I haven't been working on that much, actually. I was really busy at work, but I don't have anything to show for it here. But what I did do is I've completely set up, minus calibration, my Prusa MK, the MK3 3D printer. And I was delayed. I guess it'll be a fun story, because if you look at the Prusa front panel, there's a rotary encoder, and then there's a giant button, and it says X on it. So when I plugged it in and I started trying to use it, it says, please select your language. So I, turn the rotary encoder all the way to the language, English, and I press the X button, and then the thing resets. So then I'm like, okay, what the hell? So I try again, select the language after it's all booted up, press X, resets again. What the fuck? So I take the whole thing apart for the electronics, make sure I don't have any shorts anywhere. I test, continuity, no shorts. So half an hour later, I plug it back in, do the same thing, select the language, press the X button, resets. What the fuck? So I hop onto Google, constant reset. The first forum post that comes up, it just says, RTFM, the X button is reset. Turns out there's a button on the rotary encoder. So you got to select and then press the rotary encoder to actually choose your language, and the X button resets the whole thing. I don't know why there's such obvious button right on the UI that is resets. That's completely beyond me. But now, I've learned that I should read all the instructions before I try to select the language.
I feel like a reset button, it would be okay with an X as long as it's a skull and crossbones X. Then it's a reset.
In my mind, I was thinking...
It sounds like a self-destruct button to me, but...
Yeah, that's why you gotta look it up before you press it.
3D printer, build a bomb, and then use it to destroy yourself.
I was thinking PlayStation, right? X to select. It's like, okay, this is it. And it kept fucking resetting. I must have done it like 20 times. God damn it. Other than that, I've sent a lot of units to Stone Age Gamer, so you should be seeing a lot of stock updates there very soon. And I've started collecting a really nice pile of duds that I want to get around to testing, and hopefully, maybe document some of that. Put some nice test and validation procedures on my website, just to help people who are who might be handy with a scope or even just a multimeter, try to have some fun and troubleshoot their own boards if they don't want to send it back to me.
Send them to Zach. He likes broken stuff.
There you go.
Oh, Zach, I have a huge box, Zach, that just came in today. It was like the size of a guitar. I could send this in it if that'll make Candace happy.
What is that?
Those are all graphics boosters. Well, dead graphics boosters. This one, the game doesn't boot when you put it in.
Yeah, dead where they belong.
This one has sync issues.
Okay.
This one has a labeling issue because I didn't say what was wrong with it.
Yeah, welcome to manufacturing, I guess. Welcome to America.
Any status update on the Genesis stuff?
So yeah, what happened is, and I had ordered a whole bunch of those triple bypass boards, right? And they were sent. No, sorry, they weren't sent with a mistaken batch of FM power base units. They soldered a chip on there that wasn't even part of the BOM. I have no idea how the hell the factory managed to do that. So anyways, I received everything back a week ago, and they're here, they're ready for me to start testing with. But then all of last week I was out in Niagara Falls, so they're still nicely they're in the static box somewhere here, and I'm gonna get to them.
So if they were manufactured and shipped correctly, you might have what I've been lusting over for the past year and a half, sitting right there by your nutsack in your chair.
I think it's been a year, not a year and a half, but yeah.
Sounds like a worthy markup.
Yeah, I'm excited. I'm very excited, and so is everybody that's been chasing these down. Actually.
Yeah, that's right. And I'll remind people. A lot of people are asking me when I'm going to sell this. I'm not going to sell the triple bypass. It's going to be an open source design. It's going to be available to everyone, right? I'm going to provide the Gerbers and a BOM and fabrication notes and everything you need in one nice zip file that you can just send away to a manufacturer, and you'll be able to, have them assemble 10 or 100 of these for you if you want. But I'm not going to sell
great news.
So eventually, I would say like in the next month or two, things are going to slow down around here. Work is going to be less busy. I'm going to get around to doing this.
Very cool. I will help and get because there's so many different motherboard revisions for Genesis. I'll take pictures for all the simpletons like me that like the little MS Paint pictures rather than the data sheets. I'll help with a bunch of that. Hopefully, I'll have some form of the new site squared away by then anyway, so we could all throw up our pictures on there. But I'm very excited about all this stuff.
Excellent. I'm excited to put it in your Genesis 3. It's been sitting there for a year.
There you go.
I'm sure a year from now you're going to be bitching out Zach for having some of your stuff for a year. So.
Too late.
Too late, Rene. You're way off the mark.
All right, Steve, you want to go or should I?
Yeah, I could go. So, if you've been paying attention, been doing a lot of Dreamcast stuff, and last time I didn't talk about something Dreamcast, but we're back to Dreamcast. So, one thing I wanted to look at was the official Dreamcast VGA box that was actually made by Sega. It's this guy here. It's with this model. What is it? HKT8100. And so I finally got one of these, and I cracked it open, and I found some interesting things I thought would be worth sharing for people. And the first thing I noticed, right when you take it apart, is that the casing has a spray conductive coating on here, and it's conductive because if you put your probes on there, you get continuity. I don't know if you guys could hear the beeping, but so that's the first sign I saw that they might have had some EMI issues when they were designing or manufacturing this thing. And then the other clue I found to that was, so here's the guy here, what's inside the box. And if you look on where all the cables solder to the board, you see a bodged 100 picofarad cap on the line for the mode select. And so I was wondering, maybe they had some like noise problems there, because that internal node on the system gets exposed all the way through to this external box. And so maybe they're trying to filter some of that out. The other interesting thing I saw that was related to EMI, I think, I'm not sure, but there is it's not on the board, but the H and V sinks have 150 ohm resistors, but they're in here. They're in the connector plug. And I'm thinking it might be an EMI issue because on the board there's no sight for them, and maybe they had some issues. Because I know that H and V sinks that come off the Dreamcast, they have really high edge rates, really fast. So there could be a lot of EMI noise, and so I thought maybe that they probably put some something here to mitigate that on the connector end. And then another interesting thing I noticed is that there is ground on the shell of the connector, and that's actually connected to video ground inside the unit. And then there's a ground pin on the inside of on just one of the pins. And typically, if you have like an AV cable for Dreamcast, the white or the yellow RCAs are the yellow RCA cable. Its ground is connected to this video ground, and then this pin ground, which is actually audio ground, the white and red are connected to that ground, but they're separate. The only time they'll be connected together is if you plug it into a device where all of its internal RCA connections are connected together. But on this Dreamcast VGA box, they connect both grounds together right when it makes its way onto the board. So I thought that was interesting. And then there's actually some other non-EMI stuff I thought was interesting. Was they buffer audio. There's op amps for the audio because they're on the VGA end. They have a headphone line out type jack, and on the AV side they have the RCA audio. And instead of just routing the same audio to both, they wanted to isolate them and buffer them. So there's an op amp. There's two dual op amps to drive each of them independently. And I don't know, I kind of like drew the thing out, so I'll just hold it up for a bit, and then if anybody wants to reference it later, they can. So I drew out that, and then probably the most interesting thing, just in general, though I thought the EMI stuff was fascinating. It's always interesting to see what they did and try to infer why they did it. But this is probably not going to come up, and I'll try to put it up to the camera. But on the VGA output, on the sync output, there is a spot here, and it says C sync, and there's an IC that's not populated, and there's a jumper, a 2x2 100 mil footprint for jumpers. And I have a feeling that this is something they did in development. They were experimenting on sending, because that output of that IC is connected to the H sync that goes on the VGA connector. I think they were wanting to have some sort of internal option to select between separate H and V sync, or if you put the jumper in a certain spot, the other spot, that it would drive out a combined sync, a C sync. And I believe since there's only one IC footprint, I think they were using an AND gate, because that's one of the older ways that people combine sync in the past. They would AND H and V to get C sync for a monitor. So I don't know. I thought that was kind of interesting. And the other last thing, I was showing Voultar all this. He found me a picture of like one of the third-party boxes, and it was like they copied the board exactly, but then there were IC, like the audio op amps were like depopped, and they drew traces through everything. So like the series resistor, they would draw a trace. So I think what they did is they made the exact duplicate, and then they started popping stuff off and saw that it still worked, and they just went with the minimum amount,
Right.
but still worked. And so yeah, it was interesting because there's EMI filters on the output H and V syncs that go to the VGA connector, and yeah, they had the sites for them, but then just wire right through them. So it was cheap. It was cheaper for them to test it out, start popping stuff off, go into a Gerber editor, and just draw new traces around to go into some sort of functional state without having to like redesign the board at the schematic and the schematic level where you add components. Instead, it's faster to just draw in the Gerber editor a new trace through your resistor. So yeah, those are just some interesting things I I saw, and the EMI thing is interesting. It might make me a little more careful on things when I'm doing my own Dreamcast stuff. I might put because I have a feeling that the reason for the coding is they got this high-speed CMOS buffer here, and it's probably generating some digital noise. So something I got to be careful of. Maybe put some ferrite beads or something in my own stuff. So, yep, that's pretty much it.
Sweet. I guess I can go. Hopefully, while I'm going, Bob and Voultar can contain themselves from chatting with people that they are arguing with on the chat instead of paying attention. To Steve's wonderful stories.
Paid attention to everything. I'm just sort of entertained.
And when you guys type, it ends up muting microphones, so it becomes hard to hear people. So if you're gonna type, at least mute yourself.
That's why I have a mute.
I'm gonna put this right over Bob. All right, I'm going to MS Paint. I got a couple pictures. The first one is just going to be a real quick review of what I talked about last time, which is a continuation of my war on people abusing the English language. So what I just talked about last time real quick was some basic interpolation theory. And what I really wanted to get across is that this picture on the left is often referred to as integer upscaling, when really what's going on here is nearest neighbor interpolation at an integer scale of 3x. And on the right, this is often referred to as interpolation, when really what this should be referred to is linear interpolation, although that word interpolation kind of gets used for all sorts of different more advanced algorithms than nearest neighbor interpolation. But the point is, these are both integer upscales by a factor of 3. So when you're saying things look good because it's an integer upscale, this is not, strictly speaking, the correct way of saying that. Your retro content looks good through an OSSC because it's doing nearest neighbor interpolation. So that's what I talked about last time. So I wanted to extend that and give a quick diagram, maybe not too quick, on some non-integer upscaling. So what would non-integer upscaling be? I decided to show two examples here. The case of going from a 240 signal to a 1080 signal would be, you would need to do a scale of 9/2. And if you're going from a 480 signal to 1080, it would be a factor of 9/4. So the way you would do that is you would first upsample by a factor of 9 and then down by either 2 or 4. So the picture, top left, let's pretend that's our original signal. Just jumps from 2 samples that are low to 2 samples that are high, low, high, and let's pretend that just continues on forever. If you were to upsample that by a factor of 9, and let's pretend we're using an OSSC, and so we're just doing a simple nearest neighbor scaling, we're just filling in 8 pixels that are a copy of that same value each time. So I think where non-integer upscaling gets interesting is on the downsampling portion. So in the factor of 2 downsampling, what you do is you just keep every other sample. And what's interesting about this is when you do this, you hit an original sample point every other time, and every other sample. So you miss this. So if you're going from left to right on the downsample by 2 image, you grab the first red X, you miss the second red X, and then you grab the third red X. And because of this, you with this case, you get an even sampling that matches your kind of original. I don't know the correct word to describe it, but at the end of the day, you have 9 samples representing your original 2 in each place. So you can do the counting if you want to see that I did that right, but what you would end up is 9 samples low, 9 samples high, and so on. But if you were to downsample by a factor of 4, so if this original signal was a 480 signal instead, and you needed to get it to 1080, it takes a little bit longer before you get back to grabbing one of those original red X's. And a consequence of this is that you end up sampling 5 points and then 4 points. So you get this unevenness that doesn't match your original kind of scaling, right? Like you'd expect that there would be 4 points and then another 4 points that represent your original 2 and 2, but instead it kind of alternates between 5 and 4. So that kind of could add some distortion to your image, right? Because things are not the same ratio anymore. So I was actually kind of curious as to like whether this would make any difference in real world looking at images. So I coded some stuff up in MATLAB to look at if I could tell. So here's a picture of our hero Link. And the image on the left is kind of what I started with. Image in the middle is upsampled by 9 and down by 2. And the image on the far right is upsampled by 9 and down by 4. Now if you zoom in pretty close, you can see some mild distortions on this image. You can tell a little bit, but I'm not convinced that it makes a huge difference visually speaking.
Is it possible, Nick, for you to take your webcam and point it to your monitor, because we can't see? Oh, there it is. Thank you. Finally, there was a delay. I'm sorry.
Yeah, it just popped up.
Good deal.
So I mean, I can send out in some way these images. You could look at the raw bitmaps. But I just thought this was kind of like an interesting quick analysis to think about, that even non-integer upscaling, although there are quirks like this that you may run into, I don't think it's as big of a deal as people think, is kind of my main point here. I don't know if Steve wants to add anything to this. He may have some thoughts.
Can you explain again what the images are? Because it popped up like after you were describing them.
Oh, so yeah, sorry. Left is the original SNP. The middle is up 9 and down 4, and the one on the far right is up 9 and down 2. And it's just the exact same math that I was showing on the previous slide, if you had seen that. Just using nearest neighbor, upsampling, and then downsampling straight away.
So the middle picture has the alternating 4 and 5.
Right, like every once in a while you're going to get something that's not kind of proportionately the width it should be.
Yeah. Just it's not all the time, right? It's every once in a while, or is it?
I mean, it's repeating, right? Like, there's a pattern to it.
Yeah.
And if you take your cursor and you count pixels, you'll be like, okay, yeah, this thing has 5 pixels, and it's not the same ratio as this other thing, because this one has 4 pixels instead. But as far as like a visual difference, it's a little tough to tell, in my opinion.
Yeah, we have. Yeah, go ahead.
I'm sorry. I'm sorry, Steve. I was just going to say, isn't that more or less, as far as the visual discrepancies, or the discrepancies that are visual to the human eye, isn't that more dependent on the content? So, for example, if you had a background of like in Super Mario Brothers of just a brick wall, there's symmetry where there's symmetry in the frame. Wouldn't that be more of a prevailing issue than something very asymmetrical?
It might be. I mean, there are certainly places in this image in particular where I was looking more than others. Like the shield is the one place that I would expect to catch this easier, or maybe his eyeballs, just because of like the variation in brightness. But
I think a Voultar's point is, what if you had like 6 shields stacked horizontally?
right, yeah, I gotcha. Yeah, possibly.
One of them might look off or something. Yeah, no, that's pretty cool. Yeah, I think your point about how it's such a high pixel density, right?
Yeah.
You're gonna have a screen that's 1920 for a 1080p picture. You'll have 1920 on your line across, and so when you have 5 and 4 and 5 and 4, kind of like alternating, it's such a small
Right. Yeah. I mean, that's the point, right? It's
yeah, no,
yeah.
that's a cool.
Yeah, I get it.
I'm glad you did that, because it's super interesting.
Well,
Yeah. Frank mentioned I personally like games in color. Yeah, me too. It's just it turns out processing color images is just a little more coding that I was like really rushing to do and didn't have time to do across all the color planes.
Usually you test when you're testing stuff out, you're doing it on the monochrome image, and then once you finally get somewhere a little further, then you throw in the extra 2
Right.
planes.
Yeah, because it's just a mess of keeping track of variables. So I just...
So Nick, do you feel that currently, when you hear people talk about when people generally discuss interpolation, resolutions, and integer scaling and pixel uniformity, do you think as far as what most people, how they define pixel uniformity, do you think that's something that's really thoroughly understood among people who are looking for, I guess, the best representation of their video games on a panel?
I certainly think there are people out there that understand it and have encapsulated descriptions of issues that come up, like shimmering. That's more of I am doing different scales of interpolation on different dimensions type problem, right?
Right.
Like you're expanding your horizontal by X and your vertical by Y, and it's not the same, and so you kind of get that effect, I think. This is my understanding of it anyway. But yeah, I didn't want to touch on that too much. But yeah, I mean, do people fully understand? I don't know. The whole point of this is I just kind of want to push the language out there to people. And I mean, even me going into this, I didn't know if that this fact that you'd have kind of unevenness after you process the image would be visually disturbing or not. That's why I wrote up the code real quick to see. I was like, is this going to matter? I don't know. But I do know the language and the theory behind it, so I wanted to kind of share that, and hopefully people can go out and spread the good word.
Yeah, I think you should talk about this more. It's good.
Yeah, I may do one more interpolation thing next time that I have an idea for. Be a 3-part series. So,
can you put your Sharpie drawings somewhere? Those are actually pretty helpful.
Yeah, I do. I've kept them all. I need to put. Maybe I'll just throw them all to you, and you can throw them on your website or something. I don't know. I don't have a good place to store them.
The ramblings of Mr. Mustache.
Yeah.
I'm gonna recreate your X's in Notepad just to be even more archaic.
Yeah, do it in ASCII. It'll be great.
If only we had some sort of wiki to put this on, it would be excellent.
Oh, I heard that guy drank himself to death. Oh well.
All right, let's go to the group topic. So the group topic that we have written down is proper testing and validation, I guess. How did this come about? This came about somehow. I don't remember.
Let's skip over how that came about.
No.
Oh, but it's so much fun.
I mean, we don't have to mention names or anything, but just like a general. Yeah, just general notion of what the problem is here. So it was like some product didn't work, and somebody said, "Well, I tested it and it checked out fine." Was that like the notion here, Bob? Or
Bob,
Yeah.
Bob, just what happened to your I don't give a fuck mode? Just get with the.
I just called one of our lovely normal viewers a douchebag in the chat. I think I'm done with being mean for the day. So, look,
just don't drop names.
All right.
We're not name dropping.
so this is not coming from Retro RGB, Bob. This is coming from the guy that spent years of his life working for a company that I loved, making products that I thought were awesome. There's a point that Steve's going to disagree with me, and I can't wait for this, but there's a point where you just have to release something, right? So if you have a large team of people and, everybody's working on it, that point usually means that, Rev 1 has some bugs and we're good to go. If it's a small group of people, then Rev 1s are probably going to have some bumps in the road, and you kind of got to figure it out. But if the choices are don't release products at all, or just release them and, hopefully when they're released, you have a trusted group of people. For me, back then, it was customers that were like, we need a prototype now, and me just bluntly saying, it's a prototype, good luck. Like, I'll be there to support you, but don't, and everything was fine. So that's, in my opinion, it's just an opinion, stuff like that is totally cool. But then on the other side of things, there are people that don't know how to test. Which means they don't even know that they're testing wrong. And when products are released that need one other person checking them, they need somebody to say things like, hey, Zach, why don't you put the silk screen that says only one console at a time? Like, simple things, not shitting on you, dude. I'm just saying, like, nobody's perfect. So I've seen a lot of products released where they didn't even ask, they didn't say, hey, let me call a buddy. You know what I mean? So that's my stance on this is, I've seen a few products this year get just dumped to market as, hey guys, look at my new product that's perfect and everybody should just buy it the way it is. And it's always a disaster.
And so I guess the problem really comes up though when a customer runs into an issue and the response is that I plugged it in and it worked, and that's not really testing, right? I think that's
that could be a year down the road too.
Right. You may not come across any flaws in the product, right?
Yeah, but I mean that's I guess you could technically say that if we as retro gamers started out by using amps without filters, and 2 years from now you realized, but you need filters in some scenarios. That's fine. That's fine. That's a minor thing in the bump of the road. But I'm referring to products that were ending in products being destroyed as a result. So,
can you give us an example, Bob?
How about you give us an example, Zach?
I'd really like to know what the hell you're talking about.
The one that I'm thinking of, the products I'm thinking of specifically, obviously, are the GameCube, the HDMI plug and back that was made with the wafer and not the individually separated. And that was somebody that we've already been down this road. I'm not going to waste everybody's time.
Yeah,
and then, of course, it was the last thing that I saw was the Super Gun, where if you just, if somebody had just said put a sticker on it, Super G wouldn't have to fix all those G SCARTs.
I understand what you're saying.
Those are the things. And I know there's a few other ones that you guys wanted to talk about, but those are the ones that rub me the wrong way because on the one hand, it's, nobody's perfect and nobody can see every scenario. But on the other hand, phone a friend. Send somebody your shit and have them look it over. So.
Well, Bob, I have a question, and this is an opinion thing. This isn't, everyone could vary on this. Assert what you want, but what do you consider a deal-breaking bug, and what do you consider it's something that we can iron out next rev in a couple of months, just but it'll be okay for now. Where is that threshold, that arbitrary line for you? That's not a smart-ass question.
No. I take that very seriously. There's two answers, but two short answers. Us as retro gamers, who are people that are building things in our basements, and we put out tens at a time. That line is if something could potentially destroy something else. So if I sell you something, Zach, and it dies in a week, my bad, here's your money back, here's another one. But if I sell you something and it kills your console, your Switch, whatever else, that's there's no excuse for that. And from a larger point of view, small companies and up, it's things that people wouldn't look back on as, oh, well, this is, oh, well, this is the next revision. Like, you can't get mad at Microsoft for putting out Windows 10 after Windows 8. You can't say, well, I want my money back. Like, that's just the way it is. But if it's something that's correcting a problem, then that's an issue. And that's why companies do recalls and upgrade plans and stuff like that. So for our little group of people, it just make sure your shit doesn't destroy other things. And that might be wrong. It's just my opinion.
Do you think a component of this, and the reason, and this isn't being smug, this is just a fact of life. The reason that we see, and this isn't a reflection on the products you just mentioned, this is just across the board, but maybe perhaps the reason we see so many things that essentially look half-baked but are brought to some kind of market, the reason that they fail or the reason they have so many problems is simply because maybe the person who is putting this together, as ambitious as they are, just doesn't have the engineering background to really understand what they need to do, or to very thoroughly understand what it is that they're trying to do and what it is that they need to kind of stray away from doing. Is that reasonable to?
It is, and I think another way to say that is not knowing that you don't know. So I was lucky enough to be around a bunch of smarter people than me for the last 10 years of my careers. So when I started selling those amp boards, I said, I'm not an electrical engineer. Let me talk to somebody that is. So then I called a buddy who basically said, well, we could talk about this stuff for hours, but the short answer is no. No one's ever going to plug this in and kill something unless the thing they're plugging into is already about to die anyway. So... But I think a lot of people have that ego of like, well, I hit auto route and everything works. Why would I have to worry about it? It's fine.
Well,
so, I love Rene's sticker to town.
Well, what I've seen from what I've seen is a lot of these problems that we're kind of talking about are pretty trivial, and with all due respect, they're very elementary. And I can see some things getting by. Everybody has things that gets by. It's just no one's we're not infallible as a species, but some of this stuff is very rudimentary. I can't think, how the hell could something like that get past phase 1, phase 2, phase 3, whatever, and it's a problem out in the open. It's just, to me, it's really interesting. That's why I asked you that.
Well, one thing I just wanted to bring up is there. So you're saying you have this this hobbyist kind of community making stuff, and they send it to their friends use it and it works great, and then they move on to selling it to the general public. I think there's one step that is hugely missed, and I've seen it a lot with component devices, component video devices, is that once you cross that line into selling to general public, you really have to do the research in the sense of that there are component video standards. There's the CEA 770.2-D, which if now you're making products that are meant to interface with that, you need to spend the $60 and get the document and read all the requirements and make sure that you are in spec. And I've seen this happen where none of that is addressed, and it's obvious that the person responsible for the design is not paying the $60 to get the document, or maybe doesn't even understand the document. But you need to, once you're at that level and you're making these types of things, you need to do that research and make sure you're in spec, because, okay, great, you're not in spec with this certain thing, like you have a voltage glitch somewhere and it works fine on all 3 of your TVs. But it's still out of spec, which means it's possible that other devices that you're interfacing with aren't going to ignore that, and they're going to cause a visual disturbance. And your justification for when that happens down the line, when you have all this stuff in the field to the general public and you get complaints like that, your defense can't be, oh, it's out of spec, but it works fine on my stuff, so therefore it's okay. And I've seen that a lot, where that defense is used, where this is not a problem because therefore it works here.
Right.
And that bothers me a lot.
I think this is a good segue into maybe talking about just in general, like as you say, just plugging it in and it works. That's not testing something, right? And I think maybe it's worth, maybe you can start by kind of going over.
Well,
like...
Rene was about to say something,
go ahead.
So I don't know if...
Yeah, I was, and I was actually going to use... wait, let me bring up my video feed here so I know what the hell I'm showing you guys. Okay, so I wanted to use my Sega CD backup RAM as a perfect example of this, right? Number one is I can take this and put it in a Sega CD, slap a battery in it, try to put a save on it, and then if it saves, I go, okay, great, it works, and I can sell it. But that would be highly irresponsible, right? Because I only checked if it worked. I didn't verify that it was to spec according to what I designed, right? And the number one reason why I hold on to so many, maybe like 2 to 3% of these is because the battery drain current is going to be too high. And weirdly enough, not weirdly enough, but the main reason that happens is because there's leftover flux from the soldering process, right? So one of the validation tests I do with these is I put the battery in, then I purposely put some test pads on 2 spots. I measure the drain current from the battery, and it has to be within a specific range that I declared was within spec of the SRAM here, because that'll be the memory retention current that the SRAM is spec'd for. If it goes too high, I know that there's probably some dirt on the board, or there might be some component that's wrong or whatever. So I'm going to hang on to it and validate it some more. If I don't do that, then somebody's going to put a battery in here and use it, and then within a couple of months, the battery's going to die and they're going to lose all their saves. So that illustrates kind of the difference between, I plugged it in and it worked great, I can sell it, or let's go through the time and take a few measurements to make sure that it actually operates within spec. And then as Voultar pointed out, well, what's the limit of, where do you draw that arbitrary line between an honest mistake and you should have caught this? Well, some of my first revs had this kind of battery holder, which is just one of the pads is actually on the PCB. So you put a square pad on the PCB, and that's the negative, and then the positive is the casing, right? And that worked great for me. And I did some tests, right? I would throw it around, and the battery wouldn't come out. But then, as it so happens, with a lot of units coming out, especially from Stone Age Gamer, we started noticing that maybe 1 in 200 or so, the battery would fall out and become loose inside the case, and the person would lose their saves if they grossly mishandled it. But still, I think that's something that needed to be addressed. So on newer revs, I actually changed the battery holster to something that holds the battery a lot more tightly. And you can throw this around a lot, and the battery's never going to come out, because it's held in all directions with this particular battery holder, and on top with the Genesis cartridge shell. Whereas the older one, it could slide out. Oh, there we go, slide out from the top. So yeah, you got to do some validation tests, and you can catch as much as your resources and your time will allow. But then there will be some future revs where you're going to say, hey, this that was stupid when I did this 2 years ago, and I should change this part, and now I've got a better product because of that.
Yeah, it was the perfect example to demonstrate that. The perfect example, because there was nothing wrong with the other one, but you've just found ways to improve it in the next revision.
I do think this raises an interesting point. I don't know if there's a good answer for it. So Steve was talking about, you can, if you're using component, you can go get a design document. And there's a very clear way to make sure the signals you're producing follow that design document. But there are other things about your device, that you need to verify, but you might not know that you need to verify those things. So we, like, even us, we have a whole document of verification tests that the design had to pass before we went into production with it. Coming up with some of those things is a little bit more art than engineering, right? There's not anything clearly telling you, hey, I need to go take my HD Retrovision prototype cable and plug it into a console for 24 hours and make sure my house is not burned down the next day, right?
Yeah.
So
those are the in my day job they call it the DVT, the design verification test. And so what it starts from is a list of requirements, right? You have a product and there's requirements that you list out. Usually if you're designing for a customer, the customer gives you requirements. Hey, I want the thing to do this. And so you have a list of requirements. And then we have a test procedure that will test to that requirement. And then we have test results and then date and initial. And if you want to see an example of this, there's actually a really good one of our old Kickstarter updates, and it kind of goes through all this engineering. I think the title of it is called Insider Engineering. So if you Google Kickstarter SNES Genesis, it should be enough to pull up our thing and go to updates and go to Insider Engineering, and we kind of cover these 3 parts of the engineering process where you have the design part, and we kind of give examples of drawings, engineering drawings we've made. And then the second part was the design verification test, and I have some snips of actual stuff from our spreadsheet that have the requirements, test procedure, and results. And just really quick, like example of that is circuit shall not draw more than 100 milliamps from the 5-volt rail. And so test procedure, generate magenta screen at 100% saturation, because that would cause your amplifiers to draw the most current. Do that, hook up a meter and see the current draw and write it down. And then it's like passed because it was 52 milliamps, right? That's one example. And that's the design
something like that, there may be a very good and clear reason why you might not want to draw more than 100 milliamps, right? But there may be other tests where the reason you kind of have to figure it out, so to speak. What makes sense for your project without a very concrete thing that you need to approach. So you may
I mean, that 100 milliamps, I made it up, right? That from, like you said, though, there's an art to it. I don't want to draw more than 100 milliamps because I feel that after that threshold, I might be causing the internal heatsink to heat up too much.
Mm-hmm.
Right.
So that's like you said, I've made that. And then there's other requirements that we have. It's like the blanking level for the Y output shall not be more than blah blah voltage as per CEA 770.2-D section whatever, right? And that's the more concrete example that you were talking about.
I mean, in anything that you design, you have a power budget anyways, right? So I mean, you have to, maybe a lot of people don't consider that or think about that, but you have to work around your power budget to make sure you're not, if you go over that, you may violate something. You may violate something else, and there you are with your finger up your butt. I pay money for that, but that's irrelevant.
Just to add some perspective on the other side, though, just to kind of bring this in a little bit, I'm pretty sure I'm not violating NDA. It's been over 10 years, but I was flown out to Intel headquarters a couple times for some very cool shit. And one of the things that they had told me there was it was like the unspoken rule that no Intel product is ever released without 1,000 people seeing it and touching it at one point or another, whether it's, the initial developers, QA, doesn't matter. From the time a product is, hey, I have this idea, to the time that you can go online and order it, it would pass about 1,000 people. And I mean, 1,000 really smart people. And they still released products with bugs that, that needed firmware updates or whatever else. So I love bending over backwards to over test things, but you're never going to get it perfect. Period. Not in the
Yeah.
first try, not ever. So I just I always try to the example I said to you, Steve, like a year and a half ago when you were on the interview. It's like my 3 categories is like, all right, this might not be perfect, but is it going to kill something now? Is it going to kill something quickly, or is it maybe kind of sort of going to kill something, but probably something else is going to kill it first? Like that's where I start with my testing. And some of the things that we've seen that were out of spec were just like that would never pass the Bob test. Like, hey, is this out of spec? Yeah, but it works. Yeah, it's out of spec. No, stop right here and move to the next. So,
Well, it's like you know what it's like. You know what another good example of that is the linear buck converters that people were replacing. They're not linear. The switching regulators that people were taking out the linear regulators in there, like their NESs and SNESs, and putting this small buck, this switching supply, and the oscillation off of that thing, and among other things, yielded a pretty shitty picture in a lot of cases. And
yeah,
so,
and I was guilty of that too. I never sold it, but I put the guide up on the website saying that people were testing it, and I tested 2, and both were fine. No rippling effects, no anything. But once again, that was just me saying, "Hey, somebody said this. I've been using it. See what you think." I didn't sell the product. I didn't get up and say, "Hey, everybody buy this thing." I just presented it for what it was. So
well, right, exactly. But it's just the point. The point remains. When when you can see that power, that 60 hertz power, cycle in your picture, you might want to go and look at your testing standardization. I don't know.
yeah, that one, not to get off topic, but that one kind of blew my mind. I think it was Mark actually started sending us pictures of that, and I'm going, geez, what could that be?
Oh, I knew immediately what it was, but nonetheless, it's a good point though. Good points, everybody.
So ultimately, so the designer and seller are responsible. So even if it's something like that, you're all in spec, but there's some compatibility issue with something that you've discovered down the line, you have to make the decision to correct that, because it'll cause a lot of headaches with your customers. And is it less of a headache to change it versus leave it the same and deal with whatever comes up in specific small cases, or you got to gauge that. So you just do your best the first time around. Like, try to be as careful as you can without impacting the schedule completely. Like, Bob, I just want to point out, I didn't disagree with anything you said. Oh. Steve might disagree with me. No, I mean, I work at the day job, and we have deadlines and schedules. I know, and me and Nick shipped stuff I wasn't completely happy with too, and we've changed it later, done other stuff. So.
I think another story kind of similar to Rene's that I think is worth telling, and I know we've kind of probably brought it up on here before, but there's new people on here that may not know. Kind of a big piece of testing and validation of our cables was a test fixture device that we had to build, and they would not go into manufacturing without this device, right? So our cables coming off the line are not just kind of plugged into a TV. Oh yes, they work. Ship them out. That doesn't happen. What actually happens is the circuit board is produced. This sits in a test fixture. Known inputs are fed through it. Yep, he's got one right there.
Nice.
Known inputs are fed through that thing, and the other end,
Nutcracker.
output end measures them and checks to make sure that everything makes sense. And are where they are supposed to be. So that happens before that circuit board ever gets molded into the cable. And then once the cable is fully built, the cable itself is plugged into this test fixture, and another set of tests are run. And this is done for both brightness switch positions. This is done for whether or not there's a audio jack plugged in to the Genesis cable, because we have that jack that lets you route audio from the front of a Genesis 1. So all that stuff gets tested, and it gives them a yellow when it's running, and then when it finishes the test, it'll say green or red, this passed or failed. And there's a whole series of tests that are run during that, after that button press happens. Everything from running through different screens, like a lot of like the stuff you would see on our test software, like a blue screen. Does that go in correctly and come out the same way? So that all had to be designed to make sure that, look, it failed.
Well, I had it on debug mode, so I had to keep pressing the button. But normally, you press the button and it does the yellow, and it's like you said, it's generating patterns and measuring the outputs, and then it'll spit out the the final value. So because this board is blank, it's that thing is doing what it's supposed to. It's detecting that it wasn't built properly because it wasn't built at all.
Yeah, I do have to point out that gigantic switch on the top made Steve look so much cooler just now. You just looked like you were about to throw a mad scientist switch. Right?
Oh yeah, that thing is awesome.
Oh yeah, it's a lever. It's like the Chuck Norris lever.
Interesting total side note is that the factory just contacted us and asked if we could send them another one of those things, because I think they have two, and it's like a bottleneck because they have to do so much testing, and they don't want that slowing them down. So, actually, the whole process of designing those tests itself is a very interesting engineering problem, and there's another Kickstarter post called Monte Carlo Night or something like that talks about the development of those tests, because you can't just deterministically say, like, I'm feeding in 1 volt on this end and I should read out a half a volt on this end. That doesn't work that way, right? Your inputs have some randomness to it. Then every single component on your board has some randomness to it, and then so your output's going to be a bit random. So you have to be willing to accept a range of values, and determining that range of values is kind of laid out in that post, and it's pretty interesting to read. Too in depth to really talk about, but worth a read.
But I think your point is good, and it kind of actually, the factory test is completely separate from the design verification test. So you're testing to see if the design is good when you're doing those tests, and then now you're doing a functional test, an acceptance test, where it's a completely different mindset. You're trying to exercise certain paths on your circuit to make sure that those are built correctly versus designed correctly, right? It's a more of a manufacturing mindset type test.
Right.
And so you have to design tests that are like, okay, if this was missing or if this was the wrong value, this would fail.
I mean, it's still that same kind of mindset in the way that you have to have it usually just comes from years of experience of understanding, like, how to approach this problem. Do I need to consider what's going to happen if this capacitor doesn't get placed on the board? Or what happens if this resistor becomes a short? Those type of things. Like, what do I look for to know that my circuit is not performing properly?
Right. And that has to be built into the design, too. Like, we had to put those test points in certain spots when we built the board.
Right.
Like, it's not an afterthought, really. You have to have this in the design, like hooks to allow you to do proper factory testing. And it's tough to do, man. This is not easy. This is a reason why this stuff takes forever.
I mean, the whole point I wanted to get across with this is just that plugging something in and seeing that it works is not an acceptable level of approaching a product that you're going to sell. I mean, if you're designing something for yourself to sit on your desk and it works for you, great. And you don't care if, one day it doesn't work in some other scenario, fine. But when you're approaching a larger consumer-based market, these are the things you have to start to think about. Otherwise, your life is going to be a living hell when your customers start contacting you and you don't know how to deal with it. Unless you want to go the approach of just ignoring your email or not giving people a way to reach you.
Yeah, Nick, like I don't think this is an issue of scale, right? I mean, people don't have to go out and build a bed of nails jig like you guys showed us, but
Sure.
if you're going to be selling any amount of product to any single or multiple persons online, I think it's due diligence. You have to validate every single product that's going to go out the door, right? And I think that's just being a responsible merchant.
Totally agree. The only reason I mentioned scale is, let's say you sell 100. Let's pretend we sold 100,000 component cables or 1,000,000 component cables. Even if we had an extremely low error rate, right? 1%, 0.5%. That's a lot of people emailing you. We would never get anything else done if we didn't have some things in the middle there to cut that error rate down as low as possible. Obviously, we didn't sell 1,000,000 cables, but you could see where this could start to become a real problem at scale if you don't figure out ways to reduce that error to as small as you possibly can.
So, for people that are new to this and that they want to try to mess with their own things, basic tips for starting out would be try to find a spec that you're designing to. So I guess because it's super easy, an example, like if you're making a component thing or a SCART thing, just buy that spec and make sure that the voltages that you're outputting don't violate that spec. Seems pretty basic, but what other tips can you give people that are looking to do a product or two that are good jumping off points?
Well, like you said, there's spec, and the other thing is use case. You got to think of as many use cases as possible. Those are the main two things.
Use case is a big deal because a lot of people, when I was trying to see if maybe we could come up with a retro gaming connector standard, which we all came to the conclusion it's just not going to work unless we custom made 1,000,000 connectors. VGA was something that a lot of people suggested. Why don't you just use that? And it's because of the use case of as soon as the group of people that watch our podcast, are out of the picture, everybody's going to look at that and go, oh, it's VGA, and plug something in. So, yeah, you're 100% right on that one.
I think another easy one to do is power consumption, where you have to characterize what's going to be the power consumption of your device in these use cases and just measure that, right? Because if the power consumption's off, there's definitely something wrong with that particular unit. That's
Voultar, you were going to say something? You were going to say something, Voultar?
Well, I was going to say, we all have good ideas. And if there's something that I want to do that, say my skill set is here, but what I want to do is here, learn everything that you can before putting anything down on paper and get yourself pretty.
Uh-oh.
If you start.
Oh, no, he's back. Yeah, you froze for a second. You're good.
Repeat the last sentence.
Yeah.
Well, what I was saying was, if my skill set's here, for example, and I want to do something really awesome, but it's just right here, before you put anything on paper or you even mention it in a form, try to elevate yourself to here. Because if you try to tackle something that's out of the realm of your ability, you're going to have nothing but trouble all the way through. It's going to take you forever, and more often than not, by the time you do get something done and out, it's going to have a lot of problems. So, all the sort of the corner case study and just making sure you cover all those bases. That's great, but I think it's really important just to really self-evaluate yourself and where you are in terms of, I guess, your skill set knowledge, and make sure what's here matches here, or at least it's pretty close. That's my advice.
Something I would say, which is kind of more general, if at all possible, get a job in this field working for somebody that does something similar. I mean, Steve works for a company that doesn't do anything with video game work anymore, but it's analog circuit work, and there's a lot of stuff that he's learned there that I'm sure he's put into practice at HD Retrovision, right? Like that stuff is you're working with people who've been doing this a lot longer, and you learn something for sure. So, and you don't even have to, like, Steve's a design engineer over there, but even if he was working like in the factory as the guy doing some like assembly of circuit board, just being around the stuff and learning from other people around you, I think that would be extremely valuable, because then you kind of understand all the different aspects that a real company is going through to put a product to market.
Yeah,
Yep.
that's a good point. That's a very good point. There's a lot of people who work at our factory at my day job where I can see that if they were they're not the engineers, but if they wanted to design something, I don't think you need to be an engineer to design something. That's not the point. I don't want that to come across like that. That they would be more well equipped to making something more generally used, because they have that experience in the factory of testing stuff and asking questions like, why is this like this? Why am I doing these tests? And if something needs repair, know that repair process, all that stuff. That's so important, so huge.
Yeah.
Yep.
Agree.
Well, if anyone has anything else to say on this topic, go for it. Otherwise, we got a shitload of questions to tackle.
I want
That's a
Rene to
question.
say something. Rene, say something smart.
And
Or
say it
not.
in French, because you sound all smooth and shit.
You
All right.
have experience. You have experience in this stuff. Is there just some like really quick example?
I have a really quick and dirty example. Well, I used to work in the electronics field. Right now, I work in IT because I moved it to the North Pole. But where I first worked, we did a lot of work with lithium-ion battery packs. We designed protection circuitry around those. And one of the engineers, a mechanical engineer, was the only one that worked for us. He made a jig that had cutters on them to cut the battery tabs off of our packs, because they were maybe an inch too long to be soldered onto the boards that we made. So he made this nice acrylic jig, and it had, and you guys are all going to spot the problem here. So you've got the two battery tabs, positive and negative, and he made a nice jig with one giant pair of scissors to cut the battery tabs. Right, so he spent all this time perfecting the design and the acrylics and whatnot, and then he puts it on the floor and he says, great, now the assemblers are going to use this to cut the battery tabs. And we're like, fuck, no, don't do that. Right, so like Steve said, right, you can be an engineer, you can be the wrong kind of engineer, it doesn't matter, right? If you're not well versed in what it is that you're trying to do, right, if you're going to cut the positive and the negative of a giant 54 amp hour cell with one pair of scissors,
You're gonna
be
die.
doing some arc welding. Oh yeah, there's going to be some sparks flying around. I thought that was the funniest thing ever, right? I mean, luckily no one died using that thing. And in the next few days, he redesigned the jig to use two pairs of cutters that, you know, wouldn't short out the battery. So that was a great example.
I knew you had something.
All right, so
I wish we would have kept that on display somewhere. Just right, don't do this.
let's answer some questions. Jeez. What would you recommend for starting out with basic PCB design?
I would initially have said Eagle, because there's so many libraries, and Sparkathon has a library, and Adafruit has a library. Nowadays, if you're going to learn something, I feel like KiCad is the way to go, especially if you're doing open source stuff. If your intention is to make stuff open source, then I think you have to do KiCad, because if you want the most amount of people to have access to every part of your design and improve upon it and release new branches or whatever, it have to be KiCad. I mean, I still use Eagle. I have I paid for the commercial version of the light edition, but the light edition for hobbyist use is free. But they changed their licensing structure recently, so
What about
I don't know.
what about learning like principles of board layout? So
It's just like software, right? So if you learn like one language,
right, I'm just
that's-
looking for like where
Yeah.
would somebody go to like learn things like I don't want a shitload of right angles in my PCB design and that type of thing, rather than hitting the auto route button.
There's a great book I have on that I bought probably 10 years ago. I should get it off the shelf. Maybe we'll put it in the description if people are interested in looking for it on Amazon. But it was a college textbook, I think from 2000 and maybe 2004, and it is an excellent resource for sort of best practices for routing and layout. How to mitigate certain trace inductances, how to ensure that you have good isolation for power and other maybe high speed signals and things like that. I think that board routing is 50% science, and I think it's 50% art, and it's a marriage between the two.
I agree.
Lots of data sheets for like crystals or even CPUs, right? They'll tell you this is the recommended layout for critical parts, right? Like around the oscillator pins of a microcontroller or a CPU, it'll say, well, you need to put some ground shield around that, stuff like that. So not only do you have to be familiar with these strategies for like Voultar mentioned, but you have to look at the specifics for the parts that you're using as well, and whether that's in a data sheet or it's even worth going on the manufacturer's website to look if there are app notes if they've made a board using that particular part or those particular chipsets to make sure that you're following their recommended layouts.
Yeah,
I think that if you're starting out and you just want to dick around, I think Eagle gets. I use if I want to whip something up really fast, I'll typically use Eagle for most of it. I alternate between Eagle and Altium. Now, a lot of people have kind of shitty things to say about Eagle, but this is just my opinion. The people who have bad things to say about Eagle don't know how to really exercise and use Eagle. If you know how to use Eagle and you know your way around it and all of its little nuances, it's a pretty competent and fairly powerful CAD software. So I would recommend if you're not committed to doing anything, but you just want to play around, go grab Eagle and dick around for a week or two, and you'll pick it up fairly quickly, and that would at least get you started into doing whatever you wanted to do. That's just my opinion.
I started with Eagle, and I found some like video tutorial series, like 10 little videos that kind of just walked you through the basics and something like that.
Yep.
Yeah, I guess important to note too would be if you're gonna be starting off with whatever package it is, because they all have their advantages or disadvantages. If you're gonna be starting off with a piece of software, just try to make a simple board with, maybe something like a 555 timer and to flash an LED, something really simple, so that you don't get lost in the intricacies of that piece of software. Because at the very lowest level, most of these CAD softwares are pretty much the same, right? So, and the point is you want to get the concept of PCB design and schematic design, and not necessarily try to learn the intricacies of that particular piece of software. Sorry.
Yeah, I like that. One step at a time. Start with a note, then a chord, then a John Petrucci solo.
Right.
Nice.
Or a Kurt Cobain solo. If you're, if you're
What
feeling,
the fuck is that?
if you're
Oh,
feeling,
snarf my Bud Light, you asshole.
if you're feeling ambitious, start with a Kurt Cobain solo.
Oh God.
Does anyone know the correct combination of capacitors and resistors for connecting a Neo Geo MVS to a Framemeister?
I can answer that.
You need an IC for that. I wouldn't recommend driving that into a 75 ohm.
Yeah, you've got on the JAMA edge of the MVS, you've got your binary weighted DAC, and that jams out of the interface. But what you would really want between the JAMA interface going to your Framemeister and the MVS is you want to put a buffer in there and you want to drive those video lines off of a buffer. You don't want to connect those and interface those directly to any sort of 75 ohm impedance equipment. Fuck no.
100% agree.
I really can't answer that other than say don't do that. I'll have a better answer here for you soon.
Alrighty. How much of a difference in quality is there between a stock one-chip SNES with HD Retrovision cables versus same with a good quality SCART cable, if any? And this is all run through an OSSC. I mean, if it's a really good quality SCART cable, I don't suspect there'll be any difference for you.
The only thing I can mention is that on a stock one chip, the HD Retrovision switch is designed to properly attenuate because it's going to be a little too bright on the output, and that's if you put the switch in the dark setting, it's meant to for that specific use case actually one chip out of the SNES, and then if you're doing it with a SCART, I guess hopefully nothing gets clipped by the point the OSSC gets it, and then after that you can use your TV or whatever settings to adjust it down. That's the only thing I can think of. I think Bob has had the most experience with this. So what do you think, Bob?
I mean, going through an OSSC is a way easier explanation than going into a PVM. And honestly, I'm not even sure. Toggle the switch to the right position, but other than that, it's pretty much identical. The only preference I have one over the other is if you're going through a switch. So if you have like a G-comp switch, just throw in the component cables to make it easier. If you have a SCART switch, go with SCART. But right now, like sitting 2 feet away, because my apartment's only 8 feet by 8 feet, I have the Retrovisions going into component for Genesis. I have SNES with SCART, and then I think I have something else through another console that I made of VGA cable. So I essentially use the OSSC as a switch, and the quality is identical through all of them. It just, it's whatever's easier for your connection setup. So
I think that's a good point, because I think that's the reason why he asked that question, because he wanted to hook up a bunch of things at the same time to the OSSC. And so if I hook up something with the SCART input and something on the component input, should I have both on one or both on the other, or is it okay to do it separate? And I think that's exactly.
Yeah. And if that's the choice, it's actually I found that whatever magic you stuff into that cable, it does filter out some of the weirdness on Genesis consoles. So that's why I specifically have the rectals on Genesis and not SNES, because it makes it look better. You got to toggle the switch correctly, obviously. Make sure you're not using the SMS setting for Genesis. But yeah, I mean, it's way easier with an OSSC. If you were asking the difference going into a PVM, which I've tested a lot of you guys cables on those, the answer is which one of you spent more time tweaking the settings for. So if you have everything calibrated under component, it's going to blow away the RGB side. If you're one of those freaky people like I sometimes am, and you calibrate both, good luck trying to figure out the difference between either.
Yeah, I think constraining the problem, though, OSSC actually gives it like some sort of an answer versus universally there's infinite answers to this question.
Yeah, so with OSSC, just do whatever's easiest for your scenario, I guess.
Alrighty. My budget 4K TV ended up being compatible with all OSSC line modes, and had 12 milliseconds of lag. It was able to beat games like Ninja Gaiden and Mega Man X without perceiving lag at all. Is it uncommon for a flat panel to perform that well with the OSSC? Not sure exactly what the right answer to this question is. The OSSC is not going to be adding lag, so the real question at the end of the day is, how does the flat panel interpret whatever you're using the OSSC to do? So I could conceive of a TV, I'm just making up a fictional TV that handled 480p out of the OSSC really well, and then for some reason didn't handle 240 very well, or didn't handle 1080 very well. Like, the TV is going to add some lag based on what it's given, I suspect. Or it could be identical across all those things. And as Voultar knows, it can be different depending on what input you feed your HDMI plug into. So I think that's kind of like a long-winded answer of it. Is it unusual? I don't think it's unusual. Just varies from TV to TV and input to input and resolution to resolution.
I think it's a reasonable result, though, because let's say you are pumping, let's say 1080p out of the OSSC with, I forgot which mode that is, and your 1080, let's say this is into 4K. Okay, so you go into 4K. Besides some spatial conversions, which are done relatively quickly, they're done on a line, like a few line basis, so microseconds. I think that the main thing the TV has to do is let's say it's coming in at 59.94 and the TV needs to drive its LCD pixels at exactly 60, so it's probably buffering a frame in there just so it can hit its display technology correctly. So that's roughly around a frame.
It's really interesting because, I have a 2016 Vizio D58. It's a 58-inch 4K, and with the I coupled that with a CRT next to it, and from between 480p, 720p, and 1080p with a high-def NES, I averaged 12.8 milliseconds of latency. So the resolution was indiscriminate to the input latency. I'm assuming that the person has a what is it? Is it a TCL? It's that really cheap that flat panel that does HDR.
Yeah.
And it's actually a really nice TV.
For the money, absolutely. Yeah.
Phenomenal TV. So that's interesting. But it just goes to show you, it seems fairly clear to me, but people still think that all TVs, at least from my experience when people email me, that most of these TVs, for the most part, behave very similarly in terms of their input latency and sort of their screen refresh and this and that and the other. No, it's a huge landscape of differences out there when you're picking a flat panel. That's all I'm saying.
Cool. The only last I just wanted to follow up on Steve. I didn't mean to imply necessarily that lower resolutions are going to add more lag or anything like that. In general, that like Steve mentioned, that's a very fast process to actually interpolate, and nearest neighbor, linear interpolation, those things happen equally fast. So that doesn't even really matter. I was just speculating there could monitors. Be some different processing paths things may take on some fictional TV that I don't know about.
Could be.
Well, I can absolutely say that I've bought a few different TVs and monitors over the years. One monitor in specific really, really pissed me off because it was advertised as a 1 millisecond lag gaming monitor. And I ran a few different things into it, and it was about 2 frames of lag. I returned it, and then a while later, I was talking to somebody else that's more of a PC gaming expert, and they said, "Oh yeah, I know that TV, or I know that monitor. It's a great one, but you have to run it at its native resolution, or you get the lag. So unless you were running it in 4K, you would. So that whole, what resolution, does resolution affect lag? I guess it's different. Mostly no, but I've definitely witnessed it myself. So it's annoying. I was actually talking to a rep from a PC gaming monitor company a few months ago about that, and they were very, very interested and enthusiastic about taking their models that were listed as lower lag and then putting out a different, a version specific to gamers who want, almost. They were talking under 6 milliseconds of lag. So but
That's
23, 24 inches. So.
All right, here's a kind of a sad question. I'm wanting to get a Genesis 32X Sega CD combo again. Hurricane Katrina destroyed my last one. I mean, that's a real bummer.
Ouch.
I like the way Model 2 looks, but my friend swears all on a Model 1. Is there a concrete way to go, or is it all just trial and error?
If you're going to get a Model 2, I would say, and there are ways of identifying them. If you're looking at Model 2 Genesi, and you want a good model that outputs, excellent RGB, that's minimally gel bar free, and has, in my opinion, phenomenal sound, flip the Model 2 over. Look through the venting. If you see a silver shield go all the way across, put that piece of shit down and run for the hills. But if you find a Model 2, when you flip it over and you're looking at the bottom through the venting, and you see that motherboard stops in the ribs, and it only goes maybe 3/4 of the way across, and you have a big black void through the bottom venting, take that baby home. That's either a VA3 or a GOC VA4, and those are both phenomenal Genesis systems.
There's a forum post with a picture of that, right?
Yeah, Ace is here. He's the one that put him up.
I have a very biased opinion on this. I think nothing looks quite as sexy as Model 1s throughout.
Yeah, we call that the Sega Megazord, and it is
the Tower of
not
Power.
a matter of opinion. That is the best looking combination for sure. However,
you're missing the Game Genie.
Nick only wishes he could experience.
I'm not a cheater.
As some of us know, the Sega
no
CD Model 1 is a big piece of dog doo-doo. And
for reliability, I think the Model 2 CD drive is,
I do have to very slightly disagree with Zach on this one, though. I actually think that any Model 2 Genesis is going to need some kind of modification to it if you really are looking to get your best quality. So I would get pretty much any Genesis 2 that's in excellent physical condition, and then use the upcoming triple bypass board to just get rid of all the crappiness about it and just do that.
Define best quality.
But wait a minute, hold on a second, Bob. You don't have that crappiness with a VA. If you're talking about visual distortions, you don't have that with VA3s.
No, you don't, but you do have audio differences.
But the VA3 sounds, like I said, it's arbitrary. The VA3 sounds awesome, in my opinion. It's phenomenal. Drives sound phenomenally. You might not like it, Bob.
No, I'm not. It's not. I actually think
not
it's
like
fine.
it, Bob. You might not like it.
He just wants to fight you.
But the public deserves. Well, the good news is if you are interested in a Model 2 and you're not interested in doing a bunch of mods, there are plenty of.
I didn't ban him. That was his internet connection.
Yeah.
You're back, Zach.
You're back.
Okay. All I'm saying is if you want a Model 2 but you're not interested in having a bunch of modifications done, there are plenty of YouTube videos that will show you both the visuals and the audio of all the different Model 2 Genesis revisions. And if you're interested in what I consider, it's an opinion, the best of the best in terms of Model 2s in a stock form, the VA3 and also the VA4, I just don't think you could go wrong with those in a stock configuration. Period. Check them out. See, check yourself and make up your own mind.
All right, we're gonna go speed round here. 12-volt audio. Are they driving the speakers directly? This is in reference to super guns and what the purpose of that. I don't think necessarily why the super gun had the 12-volt setting, but why the boards have 12 volts. I'm not exactly sure what the question is getting at. Can
you ask it again? Can you say it again?
Why is there 12-volt audio on the arcade boards?
From what I understand, but just looking at the logic on a lot of these boards from the 80s, it's just the op amps more often than not that they chose to use, and and the chips that they decided to use, and so since so many people were using those damn things, I guess they just incorporated that into their whatever blah blah amusement JAMA standard.
And what was accepting were they just driving speakers directly with that 12 volts or?
Yeah. Well, technically a mono speaker, but it can't do stereo. But yeah, they're driving audio without any line level conversion right off of the JAMA connector and terminating that into speakers directly.
Yeah. All right. Regarding the volume slider on the Model 1 high-def Genesis consoles for stereo audio, about what setting should the slider be positioned to be the equivalent fixed-line audio that is expected in SCART standards?
I think to get that answer, you would need to do a bunch of testing. Like you would need to, I guess, generate an audio file, like maybe in DefLeMask of like maybe 1 kilohertz something, output it out the back and see what its voltage is, and then mess around with the front until you get something similar. I don't know. Rene, what do you think?
I've never tested anything like that.
Just put it all the way up to full. You'll be fine.
The just do it answer is 3/4 of the way up, but I've had serious noise issues with the slider. Everybody after I stopped trying to fix them said just spray deoxidin and then leave it overnight for it to dry, and then you don't get the noise anymore. But you get the crackle when you slide it. I'll try that again. But yeah, that was the quick and easy, probably not the right thing, but won't kill your console's answer is just over 3/4 of the way seems to be a happy level for people.
I always leave mine on 11, but
this one goes up to 11.
Modders have made CD drive replacements for Dreamcast, Saturn, and some other consoles. However, I don't believe anyone's working on a Sega CD replacement. Is it a technical limitation or just no one's gotten around to it?
It's just lack of interest.
Yeah.
I mean, the Sega CD, it's interesting to kind of look at the sort of the development line, the dev diary of that thing. Basically, the Model 1 Sega CD that we have, from my understanding, was just a prototype unit that Sega of America quickly had to piece together. And basically what you have is the result of people just bodging a bunch of shit in there. There's nothing too proprietary about the Sega CD. It's, for the most part, all off-the-shelf parts. So I think it's really just a lack of... It's so niche, it's a lack of interest.
In reference to the PS2 C-Sync mod, why not just lift the leg like a dog and add an inline switch to enable or disable composite video?
It's because of two things. The signal, when you do the mod, you first remove the resistor that sends sync into the chip. By doing that, it disables sync on green, but it also disables composite video output. So in order for you to have a switch to toggle on and off these things, you would need a three position, 3-pole switch. So was that a 9-pin switch, whatever. And that would allow you to, in almost all of the models, to do that. But it's just, if you would have to really look at the data sheet to... I wish I had like a marker and a Steve Kuloff style, like right behind me, like type of thing. But it's because of 3 pathways, and you can't just do it like that. And also the way Dan spec'd things out on his site, you don't cut anything, you remove components. So if you want to put it back together, there's no permanent damage to the machine, which I'm obviously always a big fan of. Zach, you anything to add to that?
Well, several years ago, when all of that first people had interest in it and they did it, and then it kind of died for 10 years. What you have to keep in mind with the PS2 is that the architecture changed drastically between the V7 mainboard, which is like a 39,000 series, and the 5,000 series. So the mod to implement this composite sync while nullifying sync on green, it's a totally different process. So what that means is that the procedure to do what you're suggesting would be radically different between a couple of different mainboard revisions, and so that you'd have to take so much into account to do that. It's just easier to do it, I guess, the way that people are again doing it now, and the way I see it. Because I think, Bob, you sent some of this. I sent you some documentation on this a while. I don't know how long ago it's been. You fry me up with shit, and I explained to you kind of.
It was a while, and I didn't grasp it. I was having a hard time, and I even after like actually doing the mod myself, I still had a hard time grasping what was happening, and it just clicked one day. But that was the issue, was just not being able to understand the steps and what each step did in the process, the disabling of sync on green, and why sync on green is disabled. So what happens for the rest of the chain when you do that? That's what was confusing me, because it wasn't as simple as just, even metaphorically, cutting traces and wiring things. You're actually changing the way one of the ICs works in most cases.
Well, you're changing the behavior, and I guess the simplest way I can sum that up is there is no clear-cut way to have a catch-all solution to do what you're suggesting to do across the board. The PS2 has a lot of fucking unreally uniquely corner cases. Simple as that. As simple as I can say it.
All right. Well, I think the only real question left is, how are modern gaming systems and game developers handling input lag? And to that, I would say that is a question for the modern roundtable. But I don't think we have the expertise in that anyway.
I may have a theory. I've done a lot of sort of deving on PS3s over the course of several years, and I think the way that the Sony handled that during the 6th generation was that despite the input latency from the device, from the television you're connecting to, there is a constant and a deep controller buffer that sort of offsets any additional latency. So I think the thinking was, if your controller inputs have X amount of latency, which can often be pretty considerable, people won't notice the difference because across different televisions and different sets, because you've got such a deep latency in your controller inputs that it's already shit. That's more of an opinion than anything, but I think there are cases that lend itself. What am I saying? I'm drunk.
So you're saying the latency on the controller input dwarfs any latency that would be added by displays.
Right. Yeah. Exactly. The controller input latency sort of presides over anything that your television is doing. They didn't have to create such a deep latency, sort of a pocket with the controllers, but I think they intelligibly did that to take into account the input response on TVs. I'm pretty convinced that's what's happened there, and that's how it was handled.
Maybe it was something to do with online play. Maybe like
too. Yeah, I think it's a marriage of sort of all those things. Yeah.
Yeah. So the only time I encountered where lag was a problem with my PS3, and the game the game took that into consideration, is a game called Rocksmith, right, where you have to plug in your guitar and you play along with the TV. So when you power it up, it actually tells you don't use HDMI audio because your TV is going to add lag. So you have to actually plug in the analog audio into the PS3 and use an external audio amp of some kind in order to listen to the music so that it's in sync with whatever input signal you're sending into the PS3 with your guitar. Otherwise, the game is completely unplayable. So in that particular case, they did consider, the TV is going to add, whichever TV is probably going to add enough lag to make a guitar game unplayable, so we have to go with analog audio.
Interesting.
Cool.
Real quick, was it a version of Guitar Hero, or it was some musical instrument game on the PS3 that had you calibrate It had you calibrate your instrument so that it could compensate for the input delay on your TV. Like before you would play a song, like if you just started a new game or something on a new, you would have to manipulate the instrument with the television so that the game could compensate for the latency. I swear that's real. I don't know what the game is, but it's
Donkey Konga.
Yeah, I know what it is. It's Metroid 5. All right, sorry.
All right, let's wrap this one up. As always, if you enjoyed this, please like and subscribe and hit the little bell so you get a notification that we're going live. I don't know when we'll do this again, 2 or 3 weeks probably. Let's see, what else? Oh, if you listen to this on iTunes and Google Play, please leave us a review there. It would be nice. Even if it's tell us we suck.
That's what we're expecting.
There's reviews on that? I've been doing a podcast for over a year. I didn't even know there was reviews. God damn it.
Yeah, I mean, so the more people review your stuff on those things, the more likely you are to be like recommended alongside other podcasts. So it's worth telling people to do that if they want to. And yeah, that's it. I think we'll see you again soon. Anybody got anything else?
Nope.
Man, this one seemed like it went pretty quick.
It's a lot of fun, yeah.
Oh, one thing I want to mention. I have the same T-shirt that Steve has. I think we should throw a shout out for that. It's pretty sweet. One of the
Andrew Kuzak.
Yeah, one of our longtime fans of our products, Andrew Kuzak, sent me and Steve a little SNES custom T-shirt that he designed.
I think it's a combination of both regions of Japan and the Japanese colors with the USA kind of design.
Yeah, pretty sweet.
And you fuckers didn't send some to us? Come on, send me like a 9XL. You know it'll fit me.
Yeah, let Bob wear that in the drunk tank next time he goes in.
I'll ask if he
Fish
can.
tank.
I'll ask if he can get that put on a moo so you can wear it around.
Bob, do you want to talk about the alleged train, whatever that means, that was ran on you in the drunk tank when you were downtown?
Well, Zach, first of all, you're going to have to be educated on your nomenclature of these things because when it comes to fish, they call them school of fish. So
Okay.
All right, everybody. Okay. We'll see you later.
All right, guys. Take it easy.